Thank you everyone for coming to our talk. We're going to talk about data evolution at Inari, how we leveraged Unity Catalog and data live tables to build our first data engineering project at the company. A little bit about ourselves. My name is Kishore Sundar. I'm Senior Manager of Data Engineering at Inari.
And my name is Jonathan Long. I'm a stat data engineer at Inari. And before we get into the project, we're going to talk a little bit about Inari itself. So we are the SEEDesign company. We make genetically edited seeds that address global needs for a more sustainable food system. We do this using AI-powered predictive design and multiplex gene editing, leading to more productive agricultural outputs, requiring less resource consumption, which benefits all of us on the planet.
So predictive design, what is it? It is a set of tools and data sets that allows us to form a feedback loop using sequencing data, plant characteristic data, and field performance data to improve our edit designs. And on the other hand, we have advanced multiplex gene editing toolkit, which allows us to perform these multiple edits across multiple targets at the same time, bringing us closer to our mission of creating better sustainable food system through better performing seeds.
All right, so some quick facts about Inari, just real quick. We're founded in 2016, came out of Flagship Pioneering. We've raised over $575 million to date through fundraising, with the Series E funding coming in at the beginning of the year. We have over 300 full-time employees across 3 different sites, Cambridge, Massachusetts, where Kishore and I are based out of, West Lafayette, Indiana, and Ghent, Belgium. And we have a diversity of experience both inside and outside of agriculture, and we're coming from some of the leading global research institutions as well. If you'd like to learn more about Inari, you can always go to our website, inari.com, or come talk to us after the talk.
Okay. So what does he talk about and what to expect? Before I jump into this, some context about the data engineering team at Inari. I joined Inari in November of 2022, and that's around the time the data engineering team was also formed, and Jonathan joined shortly after. So the data engineering team at that time was really new, and we also onboarded Databricks onto Inari around the same time. So a lot of things happening at the same time where we pushed towards more data and AI into our data landscape. So our talk is going to be about our first data engineering project that we onboarded onto Databricks, how we then used that to develop a strategy that helped us for all our future data engineering projects at Inari. Who is it for? It's for everyone at this conference actually, but I would say it might interest data engineers, anyone in data management or governance more, but also anyone in life sciences in general. So it's for everyone. Okay. Before we get into the problem, this is how the data landscape at Inari looked like before we were there. We had from left to right, if you look at it, we have data coming in from our labs. We have greenhouses and farms in West Lafayette, Indiana. This data would go into some vendor software such as LIMS or ELN. I'm sorry, I don't know why that's switching. LIMS or ELN. And then we also would put it in file sharing apps such as Box or SharePoint, creating a bunch of silos there, and also a lot of S3 buckets. We had, I think, 800 S3 buckets when I joined, which is insane. And then we had some Argo workflows and scheduled cron jobs on SQL databases. This was primarily created by the existing engineering team or lab informatics team. So each of them would serve up data products for answering specific questions, but there was no way to connect them or even know that they existed unless you just knew. It was not findable or really accessible to everyone. Then this would flow into BI tools such as Tableau or other tools, local terminals, RStudio, VS Code and other terminals, but also from periodically be downloaded as reports into CSVs and shared. So lacking freshness from time to time. So what gave us the opportunity to start using Databricks really? We had a LIMS migration project in mid-2023. For those who are not aware of LIMS, it's a software called Lab Information Management System. It allows you to track everything, all operations within a lab, also inventory and various assay data and things like that. And then we had some existing data views created within the previous LIMS software database using SQL cron jobs. And these were so complex, it would take about 5 hours to execute them. And we were running them, I think, several times a day. If something fails, you have to run it five hours again. So it was kind of a nightmare. But this migration gave us the opportunity to lift and shift it into Databricks. And so these data views were also critical to key decisions we were taking on crops. So you can imagine when you make edits, some of them work, some of them don't really work. So sorry about that. Yeah, so they were critical to taking decisions on which projects and products we want to go ahead with. So what did the existing and what did the data model look like? So the existing tables were a bunch of a lot of tables in the older LIMS software, and then moving into the new LIMS software, we had 25 plus tables. It would have 10 to 50 columns in each of them, between 500K to 20 million records in each of them, and always growing. So data never gets deleted or archived or anything of that sort in these databases. So it's always expected to grow. And the outcome was 15 tables each, sort of a data product, which would be a product of joining, transforming several of these source tables and meant to answer specific questions, either scientific or operational. We wanted it to obviously follow fair data principles because it wasn't previously findable, accessible, interoperable, or reusable. So we really wanted to get that down and also have centralized governance, because some of this data had proprietary information which was not supposed to be shared with everyone. We also wanted to ensure data quality and freshness. So when someone downloads a report and puts it somewhere, it's not getting stale and getting shared around. So Unity Catalog, why Unity? I mean, I think if you were here these 3 days, you by now know why Unity, but this was, again, early 2023, mid 2023, when we were deciding. We were new to Unity, and a lot of the features we see today, like federation, were not there. But we still see the opportunity of unified governance and just managing all our data assets in one place as a big positive. So we went for that. It's just swapping on its own. Yeah, and then it also allowed us to share, govern, and manage data across all workspaces. We could also extend this to external applications using SQL warehouses and service principals. We could audit data access. We could track lineage, and it enables fair data by default. And then it also became clear at the time that Databricks were building everything on top of Unity. So yeah. The approach we took is a fairly familiar one to most of you. We took a medallion architecture approach. So bronze, silver, gold. We have raw data from all the systems of records we call that go directly into the bronze zone. And this gets pulled incrementally, either as delta tables or materialized views, depending on if it's jobs or DLT. And then we also use DLT autoloader, which is a really neat tool wherever applicable. Silver is kind of the in-between data sets, which is filtered, cleaned, and sometimes aggregated, transformed in a way that does answer a lot of questions, but it's typically coming from a single source. So LIMS data getting transformed and cleaned would create a silver data set for LIMS. And it is also used for reporting and decision making, but on the other hand, gold would be a coming together of multiple sources into a single data product, which answers sometimes more specific or broader questions depending on what you're asking. Yeah. And then Unity Catalog also, enabled us to manage and share our data. So the way we have set up our Databricks workspaces is we have our own workspaces for data engineering, but we have several data teams across the company which use Databricks and other tools to connect. So we share those through Okta groups that are managed through obviously Okta and then show up in Databricks. but also we can create service principals for any users who are not using Databricks and need access to this system. We haven't run into any sort of performance issues while querying yet, but the SQL warehouses are highly scalable, so that's really great, and we haven't had any issues there. So yeah, that's also pretty good. I hope you guys can see this. So this is kind of how it looks like from top to bottom. You can see like data sources coming in. This, as I mentioned, were your lab greenhouse field data. We had a data engineering prod workspace, dev workspace, very similarly set up. We have autoloader Databricks jobs and DLT pipelines running within each of them. Obviously, we would test and build in dev, and then once it's done, deploy in prod. And each workspace would be able to only publish to their corresponding catalog, meaning prod to prod catalogs and dev to dev catalogs. And as you can see, within each catalog, you can see like LIMS data and then enriched data sets, curated and connected data products. Unity Catalog by default allows access control, auditing, discovery, monitoring, all of that. One additional thing that we found useful is the data dictionary aspect, which is something we built on top of Unity Catalog comments, where in each table you can add comments as a definition for that field, and then pull it from the system tables to create dashboards that serve as a data dictionary for the company. So everyone has the same meaning for any data field that you're looking at. And then, yeah, like I said, we use dev for proof of concepts, user acceptance testing, or general testing, and then all the prod catalog goes for decisions and reporting, regulatory filing, and internal apps. On the bottom, huge shout out to Sigma. We use them a lot nowadays, and it's a great product to directly query our warehouse, and we just onboarded them, and we use them for a lot of our projects nowadays. Okay. What are some of the challenges we faced? Not all of these may apply today, but this is what we faced. Because we onboarded onto Databricks at the same time, we had other data teams, like I mentioned, already setting up their clusters with policies, and they were not UC enabled. So they had all these clusters that were running and ready, but without UC, they couldn't access the data. So we had to work back and fix some of that. Single user compute clusters cannot access materialized views, and streaming tables can be solved by using shared multi-user mode. But on the other hand, R is not supported in shared access mode, which creates kind of an issue because we have a lot of data analysts still using R at our company, and they find it really useful. So that's where our studio and SQL warehouses come into the picture. Enforcing granular access control can be a bit challenging when you have these service principals. We are working towards actually solving this problem right now, but yeah, that's a challenge to begin with, and you need to do something specific or have a strategy to really approach that the right way. Moving on to DLT, I'm going to hand it over to Jonathan.
All right. So yeah, we're going to talk about how we implemented our data live tables code. But first, before we talk about why we chose how we implemented it, we want to talk about why we chose Delta Live Tables. When it came to processing the data, our choices were basically our Python Databricks notebooks or regular Python files or Delta Live Tables. And so Kishore already talked about some of the incoming data and outputs that we needed, but our big requirement was that we did have a 3-month deadline. This migration was happening and was going to be completed at the end of August, and that was the date. We had to get it done. And then we needed those critical business decisions being made as soon as that migration ended. So we really needed to condense a lot into that 12-week period. So what did we consider when we were making these decisions? Well, for one thing, we are a small team. There were 3 of us working on this project, myself, Kishore, and another engineer. These were new data models for us. Going from the old system to the new system, things didn't translate very well. And as Kishore mentioned, we were fairly new to the company, so we didn't have great knowledge of the existing system. So we needed to really learn the new system as well. We did have the team that was managing that older version of the software. They were able to help us, but they were also learning these new data models. they're also trying to keep the old software running while migrating to the new software. So they had a lot on their plates during this time period as well. As Kishore mentioned, this was our first data engineering project in Databricks, which is nice greenfield. We can do anything we want, but it also means we don't have a framework in place. We don't have any patterns. We have nothing to really rely on. Even though we have experience developing in Spark, that takes time to build up. Even if you've done it before, you do it once and you kind of forget about it. And so again, building that again takes time. And I'm going to mention this multiple times. We were under a crunch under that strict deadline. So we picked DLT because of what DLT abstracts away from us as developers. For us, DLT is all about Spark data frames or Spark SQL. So again, we were entirely focused on learning these new models and building out our tables, which means we could focus on the Spark data frames, doing the ingestion and the transformations and aggregations that we needed. This meant no manual orchestration or maintenance for us. So DLT handles dependencies between views and tables for you. So we generate a number of views. And for an example, we start with our base table. We might create our set of base tables, set a view of those. We might then create views off of those first set of views, which then feed into a table, which then feeds into another table. If we were trying to orchestrate all of that ourselves, that would, that's a difficult problem to solve. And we probably would have just done it linearly, and then if we added something new, we'd probably, lose chances for errors and delay our process. So DLT creates a DAG for your data loading, and it visualizes it for you, which is really nice. And one other aspect from a performance point of view is that it does allow for concurrent loading of data between non-dependent tables, so you can get the data out there faster. And then on the maintenance side of things, because these are Delta tables, there's vacuuming and optimizing that happens. If you're not familiar with it, optimizing is right-sizing the files to speed up queries. And vacuuming is you can see basically what your data looked like. It's by default up to 30 days in the past, so you can see, oh, what did my data look like 15 days ago? And you can, you can see what it's like. You can go back if you need to. But again, building that into the process, but the longer that you go there, that increases your storage costs because you have to hold on to that data. So you can vacuum that data, get rid of it. DLT does that for you, no additional work for us. So we broke our code down into sort of 3 categories. We have our set of common views, then we have our intermediate views, and then our enriched views. So our common views were views of the data that were shared across multiple of our data outputs. So we create this once, and it's used many times throughout our pipelines. We haven't had any sort of real issue with our performance of our pipelines, but one of the things that we are looking at, that these are things that we could materialize as temporary tables to increase performance because we had some of these used pretty frequently. So we, if we materialize them, then maybe we don't have to do that processing every time we query those tables. These intermediate views that we built, they're specific to these enriched outputs. They draw on those common views or directly from the staging tables. And this is where most of the business logic lives for our code. And we broke it down into small chunks that are more readable. Some of these tables that we generate are based off of a lot of those 25 input tables that we had. And so by breaking them down into smaller, more coherent pieces, it made it a lot more readable for us. The initial, the existing code was a giant SQL procedure, pretty gnarly, really hard to follow. And then the last piece was the enriched set. These were the definitions for our final output tables and our schemas. These were mostly just left joins on our primary key, so we could join everything up for all those primary keys. We did really not a whole lot of additional processing here beyond those immediate views, but it did occasionally happen. I apologize, that looks better on my screen. What this resulted in is that we had over 100 views feeding into our materialized views and to our outputs. The lineage is tracked in Unity Catalog, and so you can see this is what DLT does for you. Within the pipeline itself, DLT creates these views. We didn't have to worry about creating them ourselves. So one thing that we did take advantage of as well within DLT is the idea of programmatic views. So what is this? Well, you can do DLT views or tables as part of your top level code, but you can also do it within a function. So that means you can create different views depending on the arguments you pass into the function. So this reduces your reuse of code and reduces the likelihood of errors because you're only defining it once and you're getting the same results back depending on what arguments you pass in. So this is a very basic example that we have here. We wanted a unified developer experience where everything was dlt.read. We didn't want to go back and forth between dlt.read and spark.read.table. We didn't want that confusion going back and forth. So we're just iterating through a list here where we're creating a DLT view based on our input tables. So that's a pretty simple example. Here's a more complicated example that we had. And we're going to talk about data lineage here, but this is internal to our own processes. This is not the Unity Catalog lineage. But within our greenhouse, so we've done some genetic editing of our seeds, and we grow a plant. And that's where we're going to be starting our journey today. So we have a plant, and we have data for that plant in our tables. Then we want to know if that genetic editing worked. So in order to do that, we need to do DNA sequencing. But to do that, we need to take a sample from the plant. So we take a little hole punch of one of the leaves of the plant, and that's a plant sample. That's recorded in the database, and there's data associated with that. Once it goes through the sequencing, we have our DNA results, and then again, that is tracked in the database, data associated with that. So we have over 20 of these parent-to-child sample relationships in our database, and we really needed these for our outputs. But all of this is tracked in a single table within limbs. And so what you can think about, though, is if we needed to link that plant to the DNA data that's coming from it, we start with that first table, and we create a data frame where we have the parent sample ID and the child sample ID, where the parent is the plant and the child is the plant sample. Then to link it to the DNA, we create a second data frame where the parent is the plant sample and the child is the DNA. So it's sort of self-joining two data frames where the join is the child of the first data frame to the parent of the second data frame because it's actually the same set of IDs. As you can imagine, if you would then have to add, say, another layer into it and another, that might start getting really complicated and hard to follow in your code. So, but the reality is when we looked at it, it's basically the same set of queries every time. We just need to change what the parent and child were for each one. So we could create views for each of these. We can create a plant-to-plant sample view and a plant sample to DNA view. And then we could use those to join things up. All of the transformations are happening under the hood, but it's much more readable for us, and we could really understand those lineages, join those things up. And what's really neat about this is that if we get a new parent-child sample relationship that comes in, all we have to do is add a tuple to a list. It'll auto-generate it as part of the pipeline, and it'll be available to us. Talking about testing some of our transformation logic. So one of our use cases is just grouping many rows into a single JSON string. Some of those keys and values needed to be transformed, and then we also wanted to dedupe those to take the latest values from our database. So say the DNA samples that we had, say we had multiple samples for a plant, we wanted to take the latest. This can be, we wanted to make sure that we had this right because this particular piece of data was valuable to our end users. But if you look at the code in the upper right, you can't test that locally because DLT doesn't actually, you can't install the DLT package on your local machine. It only runs in the DLT pipeline. But what you can do is you can extract your transformation logic and take it outside of the DLT view. That's just a Spark data frame. And so you can set up your unit testing, you can set up PyTest, you can set up code coverage, you can cover all kinds of scenarios by taking that transformation logic and putting it outside of your DLT views. So now we're going to talk about a couple of things that we did to improve our own developer experience. Databricks has covered some of these already. I'll touch on those as they do it. So the first thing that we have here is our typing stubs. So again, we were doing this a year ago. When you're programming in DLT, again, the DLT package doesn't actually exist in your local environment. You can't install it. So if you do dlt.read in your IDE, and then you try to bring up the next function, without your IDE knowing what DLT read returns, you're not going to get any sort of code hints, any code completion, anything like that. So we wrote our own typing stub to handle this, and it made our lives a lot easier. But that being said, at the beginning of the year, Databricks actually provides that package now. It's Databricks-DLT. I highly suggest that if you're developing in DLT and doing PySpark, you use this package. It is very well done. We've removed this from our code base at this point because what they've done is so much better. Developing on all-purpose clusters. Again, running DLT requires a DLT pipeline, so you can't actually run this code in an all-purpose cluster. So for us, that kind of slowed down some of our development. But we can mimic some of the functionality with a faux DLT class. This is just building some, a decorator, generating a Spark data frame, and creating a temporary view that exists only for that all-purpose cluster. So it doesn't do any of that dependency management. You have to make sure you do things in order. It is very much not a replacement for DLT, but it's just for our ad hoc development. It made things a little bit quicker for us for some of the things that we wanted to do. And then the last piece that we did is using VS Code tasks in the Databricks CLI to speed up some of our workflows. So we're using Databricks repos to manage our code. And if you wanted to update that repo and rerun your pipeline via the user interface, it can be a little bit tedious. So my workflow is that I'm working in VS Code. I make those changes, I commit it to Git, and I push it to the remote repository. Then I switch to my browser. I have 50 tabs open. I try and find my Databricks tab. I open a new tab, so I now have 51 tabs. I go to Databricks, I go to the repos, I find my repo, I switch to the new branch, or if it's the existing branch, I have to pull those changes in. Then I have to switch over to the Delta Live Tables interface, find my pipeline, and start it. Again, Databricks has done work to improve this workflow at this point, but again, that's not what it was when we were doing this a year ago. And doing all of that is really just comes down to two tasks that need to be done: updating your repo and running the pipeline. And those can be done with the Databricks CLI. So the first line of code here is updating the repo and then also using the Git CLI to identify the branch. So even if I've created a new branch for my repo that Databricks doesn't know about, you can feed it the branch name through this code, and it'll know how to pull that branch. And then the second one is just running the pipeline. I just hard code the pipeline ID, and it's good to go. And this is like the tasks.json file for VS Code, and they're build tasks. And the reason why I use build tasks is because there's a keyboard shortcut for it. So my workflow is now make the change, push it to the repository, Command-Shift-B, update my repo, Command-Shift-B, run my pipeline. It takes less than 10 seconds. So what were the results for this for us? Well, we were able to successfully complete our project in that 3-month time frame without any interruption to our product pipeline. Our end users were very happy. As with any migration, there were some hiccups along the way after the release, but we were dealt with bug fixes as we did it. And again, people were pretty happy with the results. We now have much better processing times. We're down to minutes for our processing because we're using Spark and Databricks, so we can get those data to our end users much faster. And because now we have the framework in place and the patterns that we've developed for our own development processes, we can answer more research questions because we're now ingesting more data and making it available through Unity using the fair data concepts. And lastly, the improved development practices. We've greatly increased the readability of our code, again, going from that really awful SQL procedure all-in-one to bite-sized chunks of Python that's well commented. We have our unit testing in place, and we can block deployments if our testing fails. And again, the deployment process is much easier. All of it is DLT Python code, so it's really just a matter of updating our repo in our production workspace, and it's good to go. And I'm going to hand it back over to Kishore.
All right, thanks, Jonathan. So where does that leave us with our data landscape? So I showed a different version of this same image at the beginning. You can look at that third section in the middle that we completely kind of swapped out. It's now GitHub repos that feed into your Airflow tags, go into your DLT pipelines in your dev and prod workspace. They write to the dev and prod catalogs, and then it just seamlessly goes into BI and dashboarding tools. Again, we use Sigma for BI and dashboarding nowadays, and Databricks notebooks can directly get any of this data using Unity, and we have SQL warehouses and service principals for all other use cases. But what I'm more excited is where we can go, at least in the very near term. Obviously, we can do a lot more than this, is we have started working on DLT expectations to set up a lot of data quality rules where we can set up like warnings for some of the incoming bronze data or even like the silver data sets and report that back to like data producers and say that there's a need to fix some data there. We can also then build apps that can write back to these systems where, like, if you take decision on certain data or certain entities, you can write that back to your LIMS or ELN software and create like really powerful processes at the company to improve our pipelines. And then, as I mentioned, we are also in the process of developing a data dictionary. We are obviously like very in a niche environment, so like some of the Databricks AI Assistant comments may not be accurate. We're still using it, but then we have to go and verify some of the comments it generates. But then that can be neatly pulled into a dashboard where you can like look at any data product at the company and get the same definition across the board for each entity. Sorry about that. We also have alerting where we can alert people through Slack, Microsoft Teams, but also through emails and other things. And then last but not the least, we have also like begun some ML model training on this data. Now that it's in Unity, it can directly be used in ML training using in ML Flow directly on Databricks. So what's the summary? This is basically everything that we kind of covered in the talk. It helped us break down silos, connect data between data products, which was not easy to do previously. It put us on a path of unified data governance, which obviously there is a lot of steps to go. We are trying to bring all the data within the company into Unity, which is not yet done, but we are on the path. And then it also allows us to track lineage between these different systems, different data products, and monitor data quality and freshness. DLT works seamlessly with Unity Catalog. You can just point DLT to write to any catalog, any schema, and it will do so. And that tracks lineage. And this also allows us to rapidly make changes and like deploy them into production. Data processing times from before, obviously it was not great, but it was like several hours running on Argo workflows or SQL cron jobs is down to a handful of minutes. And even those minutes are mostly cluster start times, which I'm going to cover at the end. And then we are also reusing a lot of code, configuration, and CI/CD across all our data product repos, which is really neat. So as I mentioned, cluster start times for us remain a bottleneck because we're trying to get to serverless, but there are obviously legal and IP reasons we are still not there, but we are going to get there soon. And then we are also exploring cluster pooling if that solves the problem in the interim. Yeah, that's it. Okay. Thank you, guys.
Thank you.